So welcome back. We're going to continue and start talking about building our own functions. So again, we use the def keyword to define a function, and then later we're going to invoke this. And there's a bit to it. We are defining the name of the function. In effect, we're extending Python and creating new predefined things that we can use, except it's our code. It starts with a def keyword, has some optional arguments, which we'll see in a bit. That's what the parenthesis is. And then the name, and the function names follow the same rules as variable names. And then you have an indented block, whatever code you want to do, and then you have a de-indented block, and that sort of defines the essence. The key thing here is this is not calling. It's not invoking. It's not executing. It's remembering. It's storing. It's figuring things out. So here is the output of a program that defines a function but then doesn't use it. So this is a sort of broken function. So here we go. We start x equals 5, print. You don't have to def, you have all the defs at the beginning. The def runs whenever. So, out comes hello. And then we define a function, and this says, oh, you want to make a new thing here. So I'll make a new thing. It's kind of like a variable in a sense. And then it copies this stuff, copies it up there, and says, later you probably are going to want to use this, so I'm going to remember it. So it doesn't do anything there. No output comes out. Then it says print yo, and out comes yo. And then it adds 2 to x, so x is now 7, and then it prints x, and there's no 7. There's 7. These print statements never ran. They never ran. Why? Because we did not invoke them down here. We defined them, but didn't invoke them. So let's take a look at how you invoke a function, right? You define it, and then you use it. Sometimes you define it once and use it once, but more commonly you define it once and use more than one time. Again, the store and reuse pattern. The def is the store, and the invoking is the reuse. So here's just a slightly different version of that last program, and so now it's going to actually invoke it. So x equals 5, print hello, def, so out comes hello. This produces, the def produces no output, right? But because there's a de-indent here, that is the entire blob of the code that is part of print lyrics. So it prints out yo, and now we're going to invoke. This is the call. We're going to call the function. Now the function goes up. Let's clear this. So we're down to here. Now this like suspends at this place. It's like remember to come back to here when we're done. Go up, run this code, and then come back, and then continue on. So it like leaves like a breadcrumb of where it's supposed to come back to, and then it runs. And then the print lyrics, of course, produces the 2 lines of output. And yeah, that should probably not have, that day should be up there. And then x equals x plus 2, which makes it 7, and then prints out 7. Okay, so this is the invoke or call the function. Okay, you defined it, and then later you called it. Now, in addition to just call and return and invoking, we can pass parameters in. And the example of the parameter is in the max function, we have to say, this is the thing I want you to find the maximum of, the largest thing. And part of it is in the whole store and reuse pattern, we have a few lines of code, but sometimes we want to do ever so slightly different things in the different invocations. And so we use the arguments to subtly adjust, like finding the maximum is a general thing, but what thing to find the maximum of, that makes a function that's much more useful and reusable in a lot more situations. So arguments are the thing we passed in, and we define for our functions that we're going to build, on the def statement, so we say def, greet, name a function, and then this is the arguments, the things that are coming in. Now this lang variable, in a sense, only exists during the life of the function, and it represents sort of a placeholder. It's not a real variable in the same sense. It's a placeholder that refers to how you touch that first parameter that's sitting in there. Okay, and so lang is our first parameter, whatever it is. We don't need to see this part down here right now. All we know is we're going to make a function, and we're going to take a parameter, and this lang is the placeholder that tells us what that parameter is. Okay, so within the function, we're going to check to see if the language is Spanish. If we are, print hello. Else if the language is French, print bonjour. Otherwise, print hello. We have a very highly simplified language translation system here. So the def, of course, does nothing except remembers that and defines the concept greet. So that comes down, and now we're going to call it. And that says, go look up the thing that I defined called greet. If you don't put this in, greet is going to give you a traceback. But because you extended and named it greet, so it runs in, it starts, suspends the code here, starts up here, but then lang is now an alias to en. So now we can run if that is yes, else if, I'm getting it all wrong now. Right, so en comes in as lang, we're coming in the code. If it's not es, it's not fr, else it prints hello, and then it comes back to the next line. And then we call it again, and this time es is lang, and so it runs this code and prints hola. And then next time it calls with this, and then it prints bonjour. You get the idea. So this is a placeholder so that on the successive calls or invocation of the function, we can get at whatever the programmer put in as that first parameter. And so we are saying in this definition, we are ready to receive a first parameter. Please call us with a parameter, and then we will be able to do something slightly different for the different values. So this is a reusable bit of function that prints hello in 3 different languages, and then we tell it what language at the moment that we're actually invoking it. So that's putting stuff into the function. Now getting stuff back out is the concept of returning. In the return statement is an executable statement that does 2 basic things. The first thing that it does is it finishes. Now this is a one-line function, so that's kind of redundant, but when Python goes into the return statement, it doesn't continue on to the next line. It just returns. That is the end of the invocation of that particular function. But even more importantly, it takes as its parameter. You can say return without a parameter, and it will stop the execution of the function, kind of like a break does for a loop. It's kind of a break for a loop. Get out, we're done. Don't run that next line. Get out. But it also allows the specification of what you want as the residual value in an expression. So we're doing a print, and then we're saying greet. And what's going to show up here is whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay? And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. We call the functions that return values fruitful because they produce something, but you don't have to. You can just say return, or you don't even have to have a return statement. It goes to the last line of the function, and it does a return automatically at the last line of the function. So here's a little bit of a rewrite of our little language program. We are going to create a greeting program. We're going to take the language as the first parameter. And instead of just doing a print statement, which is what we did before, this is now more like a function because it takes some input and produces some output as a return rather than just printing. It's a little tacky for a function to print. And so here we return hola, bonjour, and hello based on the right thing. So now we say print greet en, so it runs the code once, lang is en, and then it runs this code, and the residual value is hello, so it says hello Glenn. And similarly, when it runs this code, it passes es in as lang, it runs through, and it runs this statement. It does, if there was more statements, it wouldn't run them. As soon as this return runs, that says that this bit right here is now HOLA, so hola Sally. And the same with French, goes in, runs again, out comes the return statement, and then bonjour Michael. So you see how we can control as we're writing the application, we can control as we're writing the function what the residual value that we want to see in whatever expression is calling us. Sometimes we have returns and sometimes we don't have returns. So if you think of the max code that we talked about before, we can kind of see that somewhere inside that max code there's a return, and that's how it communicates the W back to us. So we pass in as argument hello world, it comes in as a parameter, and it's going to loop through this imp somewhere. It's going to loop over and over into imp, and then at some point it's going to figure something out and tell us what it wants to send back to us is a return statement, and so the W comes back and gets assigned into big. You can have more than one parameter, and there's just an order. The first one and the second one, 3 and 5. So 3 becomes A and 5 becomes B, and away we go. So we just use this to add two numbers, and so 3 plus 5 is 8. So you get as many as you like, and the order matters. And if you do things like you tell it you want parameters and you don't give it to them, then that'll become a traceback, and it'll blow up. You can also talk about optional parameters later. So you don't have to have return values, and that means that you simply don't call a return with a value, and return is always implicitly happening as the last line of the function. So that's kind of the basics of how functions operate, but I don't want you to get too excited about writing functions. Some programming classes are like, gotta write a function, gotta write a function. Functions, to be clear, are a very powerful mechanism. And as we write programs, 150, 200,000, 200 lines of code, 1,000 lines of code, 10,000 lines of code, the concept of a function is really important. We would go crazy if we didn't have functions. But if you're only writing 20 lines of code, forcing yourself to write a function is kind of pointless. So don't worry about maybe the lack of urge to use this. We are calling lots of predefined functions, and we will for the next couple of lectures. There will be a time when you go like, oh, I'm sick and tired of repeating myself. Oh yeah, time to write a function. So that's why we don't push functions prematurely. We just want you to know what they are, use them, and at some moment you'll be like, oh, I want to define one. But don't worry about, it might take a while before you really want to define a function. So that kind of summarizes our lecture on functions, and up next we're going to do iterations.